Hello, standard geometry students. Here I am again, ready to teach you a couple of lessons. You guys have been doing fantastic. I'm so proud of you. And do encourage each other. I encourage you to call each other and try to help each other with homework, etc. And don't forget, you can always call your teacher or email. I have really been impressed with everything that you have been doing. Keep up the good work. I think a lot of you are going to end this year with A's. And remember, there's no EOC, so whatever grade you get this quarter will be averaged with last quarter, and that will be your semester grade. So every one of you can end the year very well. So hopefully we'll even be able to get back and see you very soon. Well, you probably are wondering why I'm holding on to an ice cream cone. Well, this is one of those times where I'm very disappointed that we don't have class today, because this would be yours. Of course, you would have decided what kind you want. This one is black cherry with chocolate, but this is what we're studying today. So I figure if you're studying spheres and cones, you would eat ice cream cones. Of course, we need to figure out a problem with this. So the question would be, if this cone were able to hold liquid and this entire ice cream sphere melted into the cone, would there be enough room? See how it's starting to melt already? Assume that the ice cream is a total sphere. I tried to make it as good as I could. And assume that the diameter of the cone is the same as the diameter of the sphere. If it melted into the cone, would it hold all the liquid? That's what we're going to be able to find out today once we learn our lesson. Okay, so today let's go ahead and take out your notes and see if we can get busy here. We are going to be learning the 11.3, and that's going to be volumes of pyramids and cones. So remember, we did these shapes already last week, so hopefully you remember what those are, where we had the pyramids and cones. Essentially what you're looking at today is really something you probably can see, okay? So remember, you can stop this at any time. Let's take a look back at our shapes here. So here we have a shape called what? Well, it's got two congruent circles. So that shape would be considered a cylinder. And here we have a shape that has just one base and one point. So that shape would be considered what? That's right, a cone. So last week we did this. We know that this one had two bases. So what we did is we found the area of one base and multiplied it by the height. Now, if I were to ask even a first grader, which of these two shapes held the same? Understand that they have congruent bases. The circles are exactly the same height. Understand also that they are exactly the same height. So if I were to put let's put this board on top of them, it's a level board, okay? So they're the same height, they have the same base. Which shape holds more? Well, you can guess that pretty quickly, can't you? Obviously, the cylinder is going to hold more than the cone with those equal bases. So we can't use the same formula for that. Now, how many of these, and I thought about even pouring them in, but I thought if I ruined my electronic devices, I'd be in trouble here for a while. So we're just going to pretend. How many of these do you think it would take if I were to fill this cone up and then pour it into the cylinder? Well, the answer is it would take 3 of them. So you can see that this is a lot smaller. It would take 3 of them to fill into the cylinder. The same thing can be said when you have a rectangular prism. In this case, we actually have a cube that has the exact same base as our pyramid. So remember, we're working with cones and pyramids. So they have the exact same bases. Again, they're exactly the same heights. Now we can see again that this one is going to be very much smaller volume than this one. And again, what would happen is if I could fill this up and pour it into this one, it would take 3 of these pyramids to fill into that prism. Now remember, the the cubes are a type of prism. Okay, so you get the idea then that we can't use the same formula. Last week, what was the formula that we used? Well, you're right. We used base area times height. Well, this week then, it's very simple. All we're going to do is say, well, it's going to take 3 of them. So I just take 1/3 base area times height. 1/3 base area times height. So the only thing we really need to look at again is, what do I mean by the base area and what do I mean by the height? The base area is just that. It's right. It's actually easier than with prisms. It's right opposite the point. So whatever is opposite the point is your base. If it's a square, then I just take length times width, or side squared. If it's a rectangle, I just take base times height. Whatever shape it is, I find the area of that shape. The height, though, is a little tricky, because when we find the height is inside this prism, or excuse me, this pyramid. So what we're going to have to look at is, I can't really draw the height. The key to these problems are, a lot of times, to be able to find a right triangle. If I make my height of my triangle on one side of my pyramid and then come out here, do you see, if I connect my 2 fingers now with a segment, how I would have a right triangle? So of course it's a right triangle. You could use a squared plus b squared equals c squared to find this height. Many times they'll just give it to you. That height then would be from that top point to the center of your base. So the base is the green, that's an area. The height is in pink. So remember, when I say capital B, that means base area. So it's really very similar to what you did before. You're just going to have to make sure you divide by 3, because it's not a prism, it's a pyramid. The same thing is going to be true in a cone, and a cone is easier to see that right triangle. I'll show you on this first, but again, it's going to have a right triangle if I just go with any slant height of my cone, go with any radius, and then go with the height in between. And you can see then again that I would have a right triangle. A little harder to see, there's a little glare on that. Okay, but I think it's easier to see on this. If I look at my height, so again, from that point to the middle of your circle is going to be your height. From the center of the circle out is going to be your radius, and your base is then a circle. So I'm just going to find the area of this circle, pi r squared, and then take that times my height. Remembering that it is a cone, so I'm going to take that answer and divide by 3. So here my base is still the base area, but it's pi r squared. So I'm going to take my pi r squared times my height, and don't forget to divide by 3. That's the key here. So it's really very heavy on just formulas here today. Just doing exactly like you did before, and then finding the volume of it. Okay, the last thing in 11.3 then is just to say they could put these figures together. So it could go back to what you had with 11.2. All you have to do is figure out what the 2 shapes are. So those are called composite figures. So it's just like we did in chapter 10, it's just putting 2 or more shapes together. So here I would just find the area of the prism. I know it's a prism because it has 2 bases. So I see the 2 bases here. I'd find the area of one of those bases and take it times the height, just like you did last week. And then I would say, oh, I also have a pyramid. So I would have the same base area as I had for the prism, and then I would multiply it by its height. And don't forget, on the pyramid, I got to divide by 3. Remember, multiplying by 1/3 and dividing by 3 are the same thing. Okay, so really a pretty, I would say, heavy on the formulas here today, because the only other thing we're going to add to that in 11.4 is the volume and surface area of spheres. So remember what a sphere is. It's just like a basketball. So we kind of talked about that when we were doing circles. It's like a 3-dimensional circle here. And a hemisphere would just be like half of it. We had the hemisphere, but we don't have the sphere. So that would be a half a circle. This circle right through the middle is called a great circle. So if they tell you they have the diameter of the great circle, then that would be all the way across the middle of that great circle. Okay? So my sphere is both hemispheres. It's just like what you have in history class. The top hemisphere and the bottom hemisphere, those would be the exact same kind of thing. Uh-oh. Guess who's coming again? Hello. Yes. And he wants to say Happy Easter, but it's going away now. Oh no, you did have an announcement. Oh yeah, the joke from last week. Well, let's stop and do that. What solid can cure strep throat? Did anybody get that? What solid can cure strep throat? A penny cylinder. A penny cylinder. Get it? Okay, this week, this one's a better one, and thank you to a student that gave it to me. Why didn't the math student share her answer? Why didn't the math student share her answer? Okay, so start thinking about that as we look at circles, because circles reminded me of that one, so that might be a hint. Okay, so now all we want to do is to find the volume and the surface area of our sphere. The volume is still just going to be working on what's on the inside. Remember, all volume is in cubic units, so all you're going to do for the volume is take 4/3 pi r cubed. Because it's in cubic units, all I'm going to do is cube it. The radius is just like what you would think it is, from the center out to one point on the circle. That would be your radius. It's half the diameter. Remember, the great circle is that circle that goes right through the center. Okay, so if they give you the great circle, they're giving you the radius of the sphere. And you just put it on a calculator from there. Remember to use your ABC button for ABC3 times pi times, and then remember r cubed means that I multiply it 3 times. So if I said that the radius was 1.5, I would do 4 ABC3 times pi times, I forgot what I just said. Let's say it was 4, what did I say it was? 1/2? 1/2 times 1/2 times 1/2. Okay, whatever the radius is, just multiply it 3 times. Okay, and if it's a hemisphere, then I'm going to do the very same thing, but I'm going to divide that by 2 because I only have half of it. So it's going to be 2/3 pi r cubed instead of 4/3 pi r cubed. Okay, so really the volume is very easy. That one's for volume also. The surface area means just what's on the outside. And if you kind of just look at that and say, okay, the outside of this hemisphere. And now let's compare it to just this great circle. Would this have more surface area if you were like to paint it or to put stickers over it, or would this have more? Yeah, you can kind of see this would have more. So basically, if you were to take this and put it up here, it would take 2 of these. So this would have a surface area of 2 circles. Oh, what's the area of 1 circle? Pi r squared. So for my hemisphere, my surface area is just going to be 2 pi r squared. I'll just use SA for that, 2 pi r squared. Now remember, area is in square units, so we're looking at r squared, and volume is in cubic units, so we're looking at r cubed. Then my surface area of the whole sphere would just be twice as much, so it's 4 pi r cubed. And then remember, we've been talking about similar polygons, and similar polygons are just a matter of what we had before. So it's just kind of a review here at the end. If you've got 2 similar figures, don't forget the perimeter ratio or any length ratio is A over B. Any area ratio is A squared over B squared, because it's area. And any volume ratio, A cubed over B cubed. And all spheres are similar. So I could always use that. So let's go back to our first example and say now, okay, it's getting there. And we're going to have to bring the cup, I think, with us too here. And say, okay, if I had this cone and I put that ice cream on top of it, see how it's all melting away? Would it fit? Well, let's see. What would I need to figure this out? Well, I would need to know the radius of the cone. So if I measured the radius of the cone and I said that that radius is 1. I'll put that back over here while that melts away. So what if I said that radius is 1? Okay, well then I would be able to do the formula for that. I'm out of whiteboard here, but I would be able to say, okay, the circle then would have a area of pi times 1 squared. And so I would end up saying, okay, for the height, I need to measure from the cone. I do measure on the inside, and let's say that's 6. So I would just simply do 1/3 times pi times 1 squared, okay? And I would end up with the whole volume of that cone as being about 6.28. Then I just used the formula for the volume of a sphere, and I wanted to summarize that here now as we look at all of this. So make sure you've got all of that. The volume of a sphere is just 4/3 pi r cubed. So if I had 1 for that radius, 1 cubed would still be 1 times pi times 4/3. Put that in your calculator and you'd get about 4.19 for the ice cream. So the ice cream would be about 4.19. The cone has a volume of about 6.28. So yes, that whole cone or that whole ice cream would melt into the cone and fit. So this would be what you're going to be really looking at in your notes as a comparison. Pretty easy day. Don't get too confused with it. If it has 2 congruent bases, it's just base times height. Remember, the bases must be congruent, but you're just using 1 because B means base area, capital B, and H is the height. So when you do the cone or the pyramid, I've got to make sure that I divide by 3 or multiply by 1/3. The volume is 1/3 base times height. Okay, and then for our spheres, our 2 formulas, volume is 4/3, so again 4 ABC3 times pi times whatever that radius is from the center to the outside, but you have to multiply it 3 times, okay, pi r cubed. And then if it's just surface area, 4 times pi r squared. It's like 4 circles. So a lot of formulas. That's really the heart of your lesson here today. So hopefully it won't be too bad, but remember, you can always call me. I would love to hear from you. And don't forget, why didn't the math student share her answers? Goodbye. Thanks for learning geometry. Remember to look at the reteach videos.